Hello student of class 8, once again I am Sudi and welcome back to my video. In today's video I will show you how to find the square root. So far we are dealing about the square of number. Now today we start the chapter, the part of the chapter that is square root. How a square root can be found out. So before we go this, so let us understand one point here is a very important thing to be remember. Okay, see, finding the square root is just like some other operation. So I will tell you one thing here. See, the inverse operation of addition is subtraction. The inverse, the opposite operation of the addition is subtraction, or the opposite operation of the subtraction is addition. We know that, isn't it? So here what happened? Now, like that, the inverse operation of square of a number. Yes, then the inverse operation of a square, or finding the square of a number, is finding square root of the number. For example, a number is there given and you are asked to find the square of the number. Okay, so a process is there in finding the square of the number. So the inverse operation of the finding the square, so say here finding square. Finding, okay. So let us say here also finding. The inverse operation of finding square of a number is finding square root of the number. So the opposite operation of the finding the square of a number is finding the square root. For example, let us see that square of 1. Square of 1 is 1. Understand? And now it is that the square root, this one, the 1 can be written as the square root of 1. This is 1. Okay, this is what. So this is what it means. Or we can write like this: square root one is 1. Means root over 1. We say that root over. So here this, try to understand this. This is called root. We read as root of a number, isn't it? And if there is some number here below, then it is that root over 1. We read this as root over 1. So this is the symbol of square root. Square root. This is square root. You see, my dear friend. See, we have here 1 square equal to 1. Square of 1 is 1. So what happens if this 2 is being on this side? Then it becomes square root x. That's why it is saying that the inverse operation of the finding square of a number is finding the square root of the numbers. Inverse operation. Inverse operation. We are finding square here 1, isn't it? And what happens if we inverse operation? Inverse operation is that if we shift this square on the other side, okay, we read this as square, isn't it? This is a square. We read square here, square, isn't it? We read this as a square. We write this as square here, but if it transfer to other side, then it is square root. Square root. It is called square root. So likewise, or because of this, the inverse operation of finding the square of a number is finding the square root of the other number. So like this, let us see some more example here. For example, you see square of 2. Square of 2, how much is that? Square of 2 is 4. 4 is the square of 2, isn't it? 2 square is 4, isn't it? Then you can do like this. 2, you can say like this, root over 4. That is root over. Now let's write again. So what happens when this square is bringing on the other side, then it becomes the square root. So 2, square root of 4 is 2. Means square root of 4 is 2. Here also, square root of 1 is equal to, no, just I'm changing the place only. So what happens? We are finding the square of a number. So finding out the square of a number is inverse operation of finding the square root. Understand? So here in the 4, on the 4, if we put the square here, then we get the 2 here as the inverse. Okay. So my dear student, once again, so this is 2 only. Okay, this is 2 only. So just have the same value here, you see. So what happened? Finding the square of a number is inverse operation of finding the square. Or finding the square root is the inverse operation of finding the square root. Okay, so like this. And another, let us say 3 square is equal to 9. Isn't it? 3 is equal to 9. So what happens when you bring the this square on the other side becomes like this, root over 9. Isn't it? So root over 9 is 3. Got it? So why it is 3? Because we know that 9 can be written as 3 into 3. Isn't it? That means root over 3 square. So we can cancel this 2 and we can write only 3. So getting 3. Finding the square of this number 3 is the inverse operation of finding the square. Okay, so like this. So let us see next. So hello students, once again. Now next topic is that finding square root by repeated subtraction. How we can find the square root of a number by this method called repeated subtraction. Okay, see, in the beginning of the chapter we have learned about that a square can be expressed, not a square root, square of a number can be expressed as the first sum of odd number. The first sum of odd number. The first sum of odd number means the first 3 sum of odd number, or the first sum of 4 odd numbers, like this, isn't it? So let us see. For example, let us say that let us go to the previous part. 4 square, we know it is 16. So this 16 can be expressed as the sum of the first odd numbers. With how many odd numbers will be there? 1 plus 3 plus 4 plus, not 4 not 3. 3 plus 5 plus 7. 1, 2, 3, 4. The first sum of the first 4 odd number. 5 plus 12, 13, 14, 15, 16. So 16. 16 is the square of 4. So 16 is the square of 4. So we can express this 16 as the sum of first 4 odd numbers. First 4 odd numbers. 1, 2, 3, 4. Understand? So as we have just know that finding the square root is the opposite operation or inverse operation of the finding the square root. So what happened here? We are adding for the square, but for the square root we are going to subtract it. So that's why we say finding square root by repeated subtraction, not addition. Addition was for finding the square. Now for finding the square root, minus means subtraction will be there. So let us see. For example, one number is given here, 81. So we are going to find out the square root of 81. The square root of 81 by this method called repeated subtraction. So what we do first of all, in the first step, 81 minus 1. Okay, how much we have here? 80. Isn't it? Then second, we have 80 minus 3. 1, 3. What is to be subtracted is the very important thing, the consecutive odd numbers. You have to subtract again and again. Start from 1. So in square, we start adding from 1 as the first, as the sum of first odd numbers. Isn't it? Start from 1 like that. We have to start subtraction. Start from the odd number 1. Only odd number have to be subtracted. The odd number 1 we subtract from here, then we get 80. From this 80 we subtract 3, then we get here 67 here. Then step number 2, we got here 67 and subtract next odd number is 5. How much we get here? 62 we get here. And in step 4, 62 will be minus 7. 7 to subtract again from here. How much we get here? We get here 55. Then after that, in step 5, 55 will be subtracted. Next is 9, odd number 9, isn't it? Then how much we get here? 46. Yes, 46. After that, how much we get here? Next step, 46. 46 will be minus the next odd number is 11. And how much we get here? 35. We get here 35. Just 1 minute, I guess. Then here's something. Look here. Not 67 is 77. Here is 72. Okay. This is not 67, 77. So then let us start from beginning. Now, yes, we got here 77. Then step number 3. Step number 3, we get 77 minus, we got 5 here. Then we get here 72. Then 4 we get here 72 minus 7. And how much we get here? See, we get here 65. I have so. Then next step we have 65 minus 9. If you minus 65 to 9, we get here 56. Then step 6, 56 will be minus 11. Next odd number is 11, isn't it? If you minus 11 from 56, how much we get here? We get here 45. Yes. Then we are still to subtract. Okay. Next, here step number 7, we have that 45. 45 minus the next odd number is 13. If you subtract 13 from 45, how much you will have here? You will have here 32. Yes. Then step number 8. 32 minus the next odd number is 15. Next number is next odd number is 15. Then we get here 17. Okay, 17. Then at last we have here 17 minus next odd number is 17. Then we get 0. Until we get 0, we will continue to subtract. Subtract by what? Subtracted. What will subtracted from the given number is the consecutive odd numbers. Consecutive odd numbers 1, 3, 5, 7, 9, 10. Sorry, 11, 13, 15, 17. So finally we got 0 and finish the subtraction. Then you see here, what is the step number? The step number is 9. 9. We got at ninth step as 0 and the subtraction is complete. So what happened? The square root of 81 is 9. It is written as root over 81 is equal to 9. So like this, we find out the square root of a given number by the repeat subtraction. Okay. So this is not a square. We are going to find out the square root. So to find out the square root, please remember that we write this root over on the number. This is called root over, or we say this is root over 81 is equal to 9. So how we get 9? You see how many steps we are counting? Step 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 steps. So this 9 will take. Okay, this 9 will take, and this 9 will be the square root of the 81. Okay, square root of 81 is 9. Like this we find out. Okay, so let us see the next topic. Hello students, once again, now the next topic is finding the square root by prime factorization. Just before we have done a method of finding the square root by the repeated subtraction, isn't it? So repeated subtraction, what we have to do is that we have to subtract the consecutive odd numbers again and again till we get the 0. Finally, when you get 0, then we have to see the number of steps. The number of steps will be the number, okay, of the square root. Understand? Yes. Now let's go to the next method, that is the finding the square root by prime factorization. The prime factorization, you know that how we can do. It's just a simple division only. So let us see how we do it and how we find out the square root by prime factorization. Let us take one example here, 324. So let us see this 324, the square root of this 324. Find the square root. For example, the square root of this 324. So by factorization means that 3 to 4 we have to be factorized. Factorization. This is a factorization. So in the factorization, what we have to do? We have to take the first prime number, isn't it 2? Then divide. 2 1 is 2. Isn't it? 1 will be moving from here, then 12, 6, then 2 here. Again we can take 2, divide this. So 2, 8, 2, 1. And now we cannot take 2 to divide this 81, so we have to take 3 here. So 3 2s are 6 and 3 7. Then we get here 3 9 and we got here 3 3. So when we get the prime number here, then we can stop here. So these are the prime factors of these 324. So this number, okay, this number can be expressed as the product of its prime factors. 2 into 2 into 3 into 3 into 3 into 3. So these prime factors, you see that 2 into 2, 3 into 3, 3 into 3. So 2 2 we can group, we can pair the numbers, 2 numbers, we can pair them. Then how we can write them? 2 to the square, then 3 square, then another 3 square. So this all can be written as whole square, 2 into 3 into 3 whole square. Understand? Okay, so far we get like this. So what happened? On this side we get 324 equal to 2 into 3 into 3. So where this square? We are not going to find out the square of this number, we have to find out the square root of this. So this square root will be here like this. So square root of 324. The square root of 324 will be yes 6 3s are 18. So 18 is the answer. The square root of 324 is 18. So like this we find. Okay, clear? Or just you multiply this because here this square actually because of the square root over here. So sometimes if you don't write this and multiply all this, also we get here. Why we cannot write is that we have to take 2 as 1. For example, here, okay, clear. For this 2, we will take here 1, and for this 3, we will take here another 1. For this 3, we will take here another 1. And multiply, we get here 18, and 18 is the square root of this number 324. So this square already here as a square root when we are writing. If you write like this, for example, okay, if you write like this. If you write like this, then you will get here square root over 2 power 2, 2 to the power 2, and 2 to the power 2, and with this all will cancel, and you are getting here 2 into 3 into 3, that is equal to 18. Like this also you can write to understand. So this is how we find out the square root by the prime factorization. Okay, so one more also we can take as an example. Let's say 81. Just so, but prime factorization is 81. How we can find out? 81 2 cannot do so 3, 27, 3, 9, 3, 3. So this could be okay. This could be as 3 into 3 into 3 into 3. 81 can be expressed as the product of its prime number. Then you can see here like this. Okay. Then next we are going to pair. So 3 to the power 2 into 3 to the power 2. So this 2 will cancel here, and we are getting here 3 into 3. That is, so 3 into 3, that is 9. So 9 is the square root of 81 is 9. Means like this, root over 81 is equal to 9. This is how. Okay, any confusion? Isn't it? So there must not be no confusion. Once again, how you can represent. Okay, we are asking to find out the square root of 81. Square root of 81, that means root over 81. So root over 81, how you can explain? Implies that, okay. 81 can be written as in the form of its product of prime number, isn't it? Just like this. Yeah. So it implies that equal to, so 2 we are going to pair, and we are having here to the power 2 to the power 2, isn't it? This root and this 2 can cancel, this 2 also can cancel, isn't it? Because of the root over. Then we are getting here only 3 into 3. That means 9. So square root of 81 is equal to 9. This is the answer we get. This is how we get the answer by the prime factorization. Means factorize the number. Prime factorization of the number. Take the prime factors of the number. Okay. Then take the prime factors of the number. Then you pair 2, 2. Okay, and take only 1 out of these pairs and multiply. Then the answer is a square. Okay, then let us see the next part. My test, then you see 90. Could this 90 be a perfect square? No, it cannot be a perfect square. So what happened? Just to see here, asking is this number 90 is this number a perfect square? Perfect square. Yes or no? We have to find out. We have to find out that whether it is perfect square or not. Okay, but you can just tell yourself that it is not a perfect square. Why? Because the number is end uh, with, with 0, which is odd number of 0. If it is 900, then it is perfect square. But it is 90, where there is only 1 0, so it cannot be perfect square. But how you can make a perfect square? What numbers should you multiply to the 90 so that you will get the perfect square? So let us see. For example, 90, 2, 45, 3, 1, 5, and 3, 5. So here we can write 90 as the product of its prime number 2 into 3 into 3 into 5. Now my dear student, you see here, these two can be paired. Okay, it's okay. In the case of the prime number 3, we get the pairs, it's okay. But what happened? These two are pairless. If we got one more 2 and one more 5, so these 2 and these 2 can be pairs. This 5 and this 5 can be pairs. And then it will become the perfect square. It will become the perfect square. So to become the perfect square 90, so we need this number to be multiplied. What is this number? This number is 2 into 5 is 10. If you multiply 10 to the 90, then you will get the perfect square. That is, if you get here 90 into 10, then you get here 900, and 900 will be a perfect square. So if you multiply 10 to the given number, then it will become a perfect square. This is how we can find out by the method of perfect range, isn't it? So see here, these two are paired, these two are not paired. Unpaired, if you take one more 2 and another one more 5, then it can be a perfect square, isn't it? It can be a perfect square. 2 2 मिलेगा तो सबका. So ऐसा बनाने के लिए दो बनाने के लिए एक 2 और एक 5 चाहिए. एक 2 और एक 5 मतलब 2 into 5, that is 10. If you multiply 10 to 90, then we get the perfect square, that is 900. Okay, and this if we multiply 10 with 90, then the number will be perfect square. Perfect square. This is one. Okay, clear. So with this, let us start our exercise. So the exercise will be solved. Okay. In my next video. So for today, I want to conclude my video session with this little explanations or little introduction of the exercise and the chapter. Okay. So here we finish our session. Okay. We'll meet again in the next video. Till then, have a nice day. Okay. Thank you again for watching my video. Bye bye.